Good. We are going to talk today. So my plan for the day is that we are going to go over the homework. We're going to practice. I think we might actually do the practice before we go over the homework, because I feel like once you've done this, then you'll feel a little bit better about what's going on in the homework. The reason I really want to make sure that we do that is because we are going to do a homework quiz tomorrow. Okay. We're talking about what's in there, and then we'll probably introduce some free fall today too. Homework for tomorrow. I don't have any other additional problems that you are required to do, or required in quotes, right? Because you don't really have to do them, but I would encourage you to. I just want you to review the homework, study for the quiz. Does that seem reasonable? And then we are going to lab tomorrow after the quiz, assuming we have enough time, and if not, then we'll get started on it at least. So I think before we do any problems, I want to talk to you just a little bit about what the quiz is going to have on it, so that we got this logistical stuff out. So if you want to write this down, this might be helpful to figure out what you need to study, what you need to be looking at for the quiz. I have not yet written it, but this is what I'm going to base my quiz on. So they're just like we did with that first quiz. We had the two standards that I was assessing. Remember, we did conversions first, and then we did the V is equal to D over T problem solving. Those are the first two standards. We've got two more that I'm going to assess on this quiz. The first one is graph analysis, and that really has kind of two parts to it. So I want to make sure that you're aware of that. So plotting points, drawing a best fit line, determining a slope. So I would imagine a problem like that would be, here's some data. Here's a graph. Can you plot those points? Can you draw a best fit line, and can you calculate the slope between those points? Does that seem like a reasonable thing? Do you feel like you could do that if I asked you tomorrow to do that? Okay. If that's not something that you feel comfortable with, please let me know so that we can go over that, because we can spend some time on that today if you want. The other part of graph analysis is reading, translating, determining information from the DVAT graphs. Displacement, velocity, acceleration, and time. That's my shorthand because I'm lazy. Okay. So that would be kind of like your pink sheet. Yes. You don't get to use it. So you want to know it, right? You want to know what the arrows are. Should we get one of these yet? Okay, I couldn't remember for sure. And then the other thing that I would definitely look at is that half sheet, was it green, that we went over, where it was given this graph, what is the velocity? What is the displacement? That kind of stuff. So something like that will probably appear. And then the other thing that I'm going to be assessing is ask you to do a couple of acceleration problems. So again, using the guess method, givens, unknowns, blah, 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 blah. We'll do this a lot today. And then picking the right equation, because that's the hardest part of this standard. Okay. Question?
I was going to say, are we going to have a key of the equations?
Yes. So I gave you that equation sheet yesterday, that orange paper. So when we're working today, I would strongly encourage that you have that out. And I think I may have said this yesterday, but if I didn't, I apologize. So the reason I give this to you is that you should never feel like you need to memorize an equation. So I printed ones out for all of you, the orange ones that I gave you. And then I also printed out some that I had laminated. So when you do a test or a quiz from now on, you will have access to this. Okay. So if you write any notes on your sheet, those obviously won't be on this one, but it looks exactly the same as it can check. Does it look the same? This one's just shinier. Let's double check in every single equation. We just really care about this top corner, right? So I want you to be familiar with this and this is kind of like your security blanket, right? This is here for you. Okay. So yes, you do not have to, or no, you do not have to memorize equations, because they're all right here. Questions? Anything else about the quiz? Does that seem like a reasonable set of things to assess for tomorrow? Okay. Just kind of a preview so that you know we've got one more little piece that we need to do. So we'll do that probably a little bit today, a little bit tomorrow, Monday. Then we're going to do a big review, and we'll probably test, I'm going to guess Wednesday or Thursday of next week, a big unit test over everything. Okay, then we'll move on to something new. Reasonable? We all right? We excited? Maybe, I don't know. Would you please go get a textbook? Because the example problems that we're going to work on today are all from the textbook, because then you have access to them and you know where they're at. Okay, so go ahead and grab a textbook, or one per pair is fine if you just want to look at it. That was magically just yeah. You will also no doubt need a calculator out today. Lots of paper. You do not need a Chromebook out. As always, you don't need your phone out. So Get yourself ready and arranged. I do intend to go over some homework questions if you want, but I want to remind you also that all of the homework answers are up on Canvas, so you can always check those. My intention is at the beginning of every new calendar that I give you that I will also put up all the answers to the numerical questions, so you have access to those as well. Okay. All right. So I picked out 4 problems that I wanted to work through today, but would you like to go over one with me first before I set you loose? Would that be a helpful thing? Yeah? Okay. So we're going to do one before this. Why don't you turn to page 51? Turn to page 51 in your textbook. And we will look at, so they have lots of practice problems in there. And if you, as you're studying, you want to know answers to them, I've got access to all those answers, so you can just like send me a message. I don't take this book home with me, so I can't tell you like in the middle of the night with the answers. All I can probably figure it out if you needed to. Okay, so let's take a look at page 51. And let's do, I don't know, how about question, I'm going to have you do question 2. Let's do question 3. Let's do question 3. Is everybody there? Page 51. We're looking at number 3. It's at the bottom in that box. So the question says, a driver in a car traveling at a speed of 21.8, meters per second sees a cat. Oh no! 101 meters away on the road. How long will it take for the car to accelerate uniformly to a stop in exactly 99 meters? So they're trying to give us like a 2 meter, buffer so that the cat doesn't like run towards us in 2 meters. That would be really sad. Okay. So I don't know how to do that problem. What are we going to start with? Always, right? These are going to tell us everything we need to know. So take a look at question 3. What is one of the givens that is listed there that you can tease out from that we need to write down? Go, Isaac, what you got?
Our speed or velocity is 21.8 meters per second.
21.8 meters per second. And is it at a constant speed the whole time? Or is the 21.8 the beginning or the end?
It'll change at the end. It's going to try to slow down.
Right, it's going to change at the end. So this would be our
What's a final?
Yeah.
initial or final. Is this initial or final? That's my question. Is there
Oh, initial.
Initial VI. Yep. What else do I know? This is where you guys have to turn your brains on because I can't do these problems for you. Yeah. I'm going to write that as delta x. You can also write it as d. Again, either way is fine. I'm just going to write delta x because that's what's printed on here. And that was 99 meters, right? So we're hoping that we can stop in those 99 meters. Yeah. Go, Malik, what you got? Absolutely, it would. Yeah, that's the sneaky one that doesn't really, it's not listed numerically in the problem, right? So we just have to read it. We have to think a little bit to figure out what that VF is. And then what is it that they're looking for? Are they looking for the acceleration? They're looking for the time. And that's the funny part, right? And this is kind of where we ended yesterday before the bell rang or right as the bell rang, was that there are 5 things that we could talk about. We know that the car is accelerating, but do we care what the value of the acceleration is? Do we need to find it? Does anybody ask us for it? No, doesn't matter. So we're going to look at, where did that go? Where's my little list? Is it here? There it is. There's my little list. So we have VF, we have VI, we have displacement, and we're looking for time. So we look at our set of equations, or we look at our chart. And again, you're not going to be able to use this chart on the test or on the quiz, but this kind of helps you get in the right mentality, right? To find that equation. So we don't care about acceleration. Which one of these equations doesn't have a check mark next to acceleration? Number 2. All right. So that's the one we're going to use. That delta x is 1/2 VF plus VI times delta t. And if you look on your equation sheet, you can take a look there and make sure you can find it. Okay. The order is a little bit different on here. I apologize for that. I didn't really think about that when I gave you your notes. But it's the third one down. I do want to tell you, I used to be really, really picky about having little lines over things, which is why there are funny little lines on these. And I should have taken them off when I was editing it, but I didn't remember to do that this summer. So just ignore those little lines that are over everything. They don't, for our purposes, don't matter. Okay. So let's take a look here. Oops, this is what I wanted. So that equation is delta x is equal to 1/2 VF plus VI times, and again, in your book, I think it's also written as delta t. I stole them from your book so that they matched your book, but you can just write it as t. Delta t just means the change in time. So that literally means, like, I look at my clock and it says 11:59, and then I look at my clock a little bit later and it says 12:01. So the change in time would be final minus initial. Does that make sense? But we don't have to do that because we kind of internalize time as just being how long something lasts. So it's a little bit of a different way to think about it, but for our purposes, you can just write it as t. Okay. I just don't want you to be bent out of shape about it. Okay. So we've got our givens, we've got our unknown, and our equation. Now we need to do some solving, don't we? I need to get TL by itself. How in the world do I do that? Divide by what? Okay, so if I divide by t, because that's what we often will do, right? Then t is going to become part of the denominator here. Does that make sense? Do we want our unknown to be in the denominator? No, that makes us that's kind of counterproductive. So that's a good idea because we often do that, don't we? We often do. But in this case, because t is already in the numerator, I'm just going to leave t alone and I'm just going to get everything else out of the way so that t hangs out over here on the right-hand side by itself. Everything else is going to move to the other side. Does that seem reasonable? How am I going to do it? Divide by everything else besides t, right? So you can do this in multiple steps if you want. You can do it in one step. It doesn't matter. I'm going to do it in multiple steps because I feel like for people that like to skip steps, you can handle doing that. So I'm going to undo multiplying by 1/2, which is also the same as dividing by 2. How do I undo this? How do I get rid of dividing by 2? What's the opposite of dividing? Multiplying. So I can multiply by 2 on both sides. Is that okay? So this thing and this thing are gone. I've got a 2 on that side. So now I have, and again, you don't have to write this out every time like this, but I just want you to see how it works. So I got rid of the 1/2. And now I'm going to divide by all that other mess that's there. We do have to remember some algebra skills in order to do this, don't we? Yeah. Yeah, go ahead. No, we just got to plug stuff in. Can we do it? Can we do it? Yes, Miss Garbling, it sounds like a great plan. Let's do it. That's awesome. I'm glad you have that much enthusiasm for that. 99 meters. Here we go. VF, is 0. That's nice. 21.8 meters per second. You have those calculators out for a reason. That's exciting. You plug those numbers in. Plug those values in. I do want you to do this. I want every single person to do it because the more you do it, the better you get at it. And if the first time that you plug something in is tomorrow on the quiz, then little things like where to put parentheses might get screwed up, and then you might miss something. Miss easy points because you just didn't practice one time. So 2 times 99 divided by 21.8. Come up with an awesome answer. Like
9.08 seconds.
9.08 seconds, he says. Cool. Would it be okay to write 9.1?
Yeah.
Sure, that's fine with me. I'm cool with that. Either way is fine. I'm not going to get anxious or cranky about that part. Let's check the units to make sure. Not that I don't trust Ben. I do most of the time. Let's just double check though. I've got meters on the top and I've got meters per second on the bottom. Dividing by a fraction is like multiplying by the... This table over here is like the quietest, but they know the answers all the time. It's adorable. They're like... Dividing by a fraction is like multiplying by the reciprocal. Woohoo! So let's do it. So we're going to do m times s over m. Just to remind ourselves, just to keep this in our heads. M on the top, m on the bottom. What happens to those? What happens to your m's? They're gone. See ya. You're left with just seconds, which is what Ben said. Nice job, Ben. All right. Doing okay? Would you like me to go through another one, or are you good to go? You want me to just like let you loose for a little bit? I have some other problems I want you to work first to practice. So this is what I'm going to have you do. I've got 4 problems that I want you to work through. These all use different equations. That's the big game. So I'm going to give you some time. I'm going to kind of come around and walk through them with you. If you would like to write them down on whiteboards because it makes you happy and like just that makes your heart happy, great. If you'd like to write them down in your notes, that's fine too. But I want you to go through those and practice with them. Okay? I'll come around, but please talk to each other. We'll pause for a little bit and then we'll regroup.
So we can write them on my phone.
Sure. I'm not going to check to make sure you have them like in your notes. You know what I'm saying?
Practice.
This is just practice. This is purely practice.